to our Monday math lesson. Today we're going to be working on finding area. We worked on this last week, but we're going to take it to a new level, take it from simple to complex today. So first, let's review some of our simple shapes. Right here we have a square or a rectangle. This square has a length of 3 and a width of 3. If it has a length of 3 and a width times 3 of 3, I know 3 times 3 is 9. So this figure has an area of 9. Next up, here's another rectangle. I see I have a length of 2 and a width of 4. 2 times 4 is 8. So this figure has an area of 8 square units. So we're taking it from simple, and today we're going to make it complex. I know we're ready because we've done really well with area. So we're going to find the area of some shapes like this. Now, in our lesson frame, we talked about decomposing. We're going to break it apart. So it'll end up being easy peasy, but I'm going to show you how to break it apart. Here's our lesson frame again. We will decompose figures to determine area. So we're going to break apart shapes to find their area. And you will use your multiplication skills to find the area of a figure. So we're going to use some of those multiplication strategies. Thinking about the model below and how it relates to multiplication, what can we call this model? An array, that's right. And it can help us determine the area of a figure. So when we did our multiplication strategies, we used arrays or area models to help us solve. This is just an array or an area model. And we've been using them to help us solve for area. Can you find the area for the model? What would the equation be? Take just a few seconds to look over the shape and think about what would the equation be? What would the area for this shape be? All right, let's continue. You can pause it if you need a little bit more time. So this shape has a length of 3 square units and a width of 5 square units. 3 times 5 equals 15, so the area of this shape is 15 square units. Here's another one. Carrie's rug has a side length of 4 feet and 9 feet. What is the area of Carrie's rug? Let's use square tiles to model 4 times 9. There's 1 unit. Let's make it 4. So I have my length of 4, now I need my width of 9. There we go. Let's fill in the space, the inside. So you know you can multiply the length and the width. So I know 9 times 4 or 4 times 9 equals 36. So the area of Carrie's rug is 36 square feet. Imagine a vertical line that breaks apart the rug to make 2 smaller rectangles with a side length of 5 and 4. What would that look like? So instead of having one giant rug, I want to break my width apart and have 5 and 4 instead of 9. What would that look like? I'm going to put an arrow right down the middle or a line down the middle to break it apart. Now this side has 5. And this side has 4. It's still the same rug. I didn't cut it apart. I didn't break it apart. That's still the same amount of square units. We just broke into 2 smaller sections for solving. I want you to think back to teacher table. When we were doing multiplication strategies, I brought in the little mini cookies, and I had the little cookie trays, and we actually did something just like this. I said, okay, let's take these cookies. Let's make arrays with our little cookies. And then you guys had a popsicle stick, and I said, put it down the middle somewhere to break it into 2 smaller parts. And when we broke it into smaller parts, we found that it was easier to multiply the 2 smaller equations rather than the larger equation. So thinking back to this little printed out, they were printed in color. I had them in plastic sleeves, cookie trays, and I gave you those little mini cookies and had you line them up and then use popsicle sticks. So think about that lesson and how it connects to this. Let's go ahead and continue. Here's rectangle 1 and rectangle 2. Don't forget, squares are special rectangles, so we can call them both rectangles. Let's find the area of the 2 smaller rectangles. Of rectangle 1, I have 4 groups of 5 now. So I have 4 times 5 equals 20. In rectangle 2, I have 4 groups of 4. So 4 times 4 equals 16. So now I found the area of the 2 smaller rectangles. I need to add our products together to find the total. So if I take both of these and add the areas together, 20 plus 16, I get a total of 36 feet. My area of my rug is still 36 square feet. It did not change. Is there another way we can decompose this rug? How can we decompose it a different way? Here's another way. Rectangle 1, rectangle 2, I just move my line. This is like when we were at teacher table and we would move the stick, the popsicle stick. Rectangle 1 now has 3 groups of 4, which would give me an area of 12. And rectangle 2 has 6 groups of 4, which would give me an area of 24. We're going to add our products together to find the total area. 12 plus 24 equals 36. So my area is still 36 square feet. Has my area changed? No. Model 1, Model 2, and now the third model that I just showed you all have an area of 36 square feet. My area is not changing. No matter how I break this up and decompose it, I'm still finding the exact same area. Now I'm going to give you a vocabulary, something that was on our math word wall. Do you remember when we talked about the distributive property of multiplication? This is it. I'm taking that large number, that 9 I had at the top, and breaking it down into smaller ones. Earlier we broke it down into 5 and 4 and multiplied it by 4. This time we broke it down into 3 and 6 and multiplied them by 4. I'm just taking that 9 and multiplying it by and breaking it down into smaller chunks to multiply, and then adding them back together. Even though we have decomposed the shapes in multiple ways, has the area changed? You should have said no, the area has not changed. Both of these decomposed different ways still had the same area. If you decompose again in a new way, do you think the area would change? Here's another way to decompose the rug. Rectangle 1, rectangle 2. Let's check. Let's see if the area changes. Rectangle 3. Do you think the area is going to change now? Did any of my squares within the inside of my shape leave? Nope, they're all still there, but let's do the math just to make sure. Rectangle 1 now has 3 groups of 4. 3 times 4 equals 12. Rectangle 2 has 3 groups of 4, which gives us an area of 12. And rectangle 3 also has 3 groups of 4, giving us an area of 12. If I add these all up, 12 plus 12 plus 12, that gives me 36. The area is still 36 square feet. Try one more time, any way you want. Here's mine. Go ahead and pause this video. I want you to cut it another way. Solve, see if you still get the same area, and then click play, and I'm going to show you my way. All right, here's my way. Ooh, did you see? I did a little flippy on you. Rectangle 1 is now on top instead of on the side, and rectangle 2 is on the bottom instead of being on the right side. Rectangle 1 now has 9 groups of 2. 9 times 2 equals 18. And rectangle 2 also has 9 groups of 2, giving it an area of 18. If I add 18 and 18, it's going to give me that area of 36. The area did not change. Did you decompose your rectangle the same way as mine? Do you think everyone in our class is going to decompose it the same way? Why do you think the area stays the same? It doesn't matter how we decompose it, it stays the same. Why do you think that? The area or the amount of space the figure occupies did not change. It's not going to change no matter how we decompose it. Using the distributive property is helpful when I have a figure that is not a perfect array. How could you break apart this figure into rectangles? One way we could do it is horizontally, going side to side. Rectangle 1 on top, rectangle 2 on the bottom. Let's find the area by writing our multiplication equation for each rectangle. For rectangle 1, I have a length of 3 and a width of 7. 3 times 7 equals 21. So rectangle 1 here has an area of 21. If I didn't trust this, I could always double check and count them. If I count them, I'm still going to find that there are 21 squares. Now rectangle 2 has a length of 3 and a width of 3. 3 times 3 equals 9. So rectangle 2 has an area of 9 square units. If I add them up, 21 plus 9, it will give me a total of 30. So all together, this shape has an area of 30. If I don't trust it, as I said, you can pause if you want and count it and make sure. But I can also decompose, use that distributive property of multiplication to help me solve. Another way we can decompose is vertically or up and down. Here's how. Rectangle 1's on the left, rectangle 2 is on the right. Rectangle 1 has a length of 3 and a width of 6. I totally flipped that. 3 times 6 equals 18. Rectangle 2 has a width of 4 and a length of 3. 4 times 3 equals 12. If I add up my 18 for rectangle 1 and my 12 for rectangle 2, it's going to give me a total of 30 square units. So this figure altogether has an area of 30 square units. Here's what we did today. Step 1, we decomposed the figure. We decided where we're going to put that stick, where we're going to put that line or that arrow, how we're going to break it apart. Step 2, we wrote a multiplication equation for each rectangle. So we took one figure, but then did 2 separate equations. Step 3, we added the products together to find the total area. So once we have the area of each separate rectangle, we added both of those together to find the total area for the figure. And step 4, you can always check by counting the squares. So as I said, if you don't believe me, pause at any point and you can go back and count the squares to see how many there are. You can always check your work this way. However, it does take longer, but as we are learning, it's a good idea to stop and count and just make sure you have it correct. I want you to find the area of this figure by breaking it apart into rectangles. This is the end of our video, so you will need to pause. I want you to check yourself. Find a way to decompose it. Maybe decompose it vertically first and then decompose it horizontally. See if you can work it with those multiplication sentences and then go back and count the squares and check yourself. Be a reflective learner. If you're on the side and you're like, whoa, I am not sure what to do here, go back and rewatch or hop onto one of my meet sessions and I'll be more than happy to help you. But this is your time. I want you to solve this, check yourself, and ask yourself, do I know this or do I need more practice? You can pause now, or I'm about to stop the video. So when I stop the video, you won't see this anymore. So pause, and when you're done, then you can head on back into our Google Slides.